Exercise 2.23. A fish exerts a 10-pound force on the line that is represented by the vector F. Express F in terms of components using the coordinate system shown. Alright, so right here we have y, positive. That means that towards this direction is negative. Right here we have x, positive, which means that towards this direction it is going to be negative. And they are telling me that the magnitude of F is going to be equal to 10 pounds in this case, because of the force that is exerting on the line. They are giving me a triangle, this triangle, which has two different components, 11 and 7. As you can see, the resultant vector is going to be this one. Why is that? Because I want it to be pointing towards the same direction of F. F is this direction. That means that I want this to be towards this direction as well. Why do I want it that way? Because for when we want to solve this exercise, we should have like pretty clear some different concepts. The first one is the unit vector. Remember that when we are talking about vectors, there are two different characteristics that are or must be important. The magnitude and the direction. For when we are talking about a unit vector, the magnitude is not important. Why is that? Because of the name. The magnitude of a unit vector is going to be always 1. And a unit vector is always represented by a little hat above the letter. That means that the only thing that we care about is the direction. Why is that? Because the unit vector allow us to change this direction and, well, to play with the vectors, alright, for when it's needed. The second thing is the reason of why I want it to be pointing towards the same direction of F. And it is because for when you have, for example, two vectors, for example, the vector u and the vector k, if both of them are parallel between each other, that means that we do not have any angle between them. The unit vector of both of them is going to be the same. Alright? That means that the unit vector of u is going to be equal to the unit vector of k. Now, there are two ways in which we can know we can find a unit vector. The first one is by using their magnitude, or the magnitude of the vector. For example, the magnitude of the vector u, of the unit vector u, is going to be, sorry, not the magnitude. The vector u is going to be given by the vector u divided by the magnitude of the vector u. Right? This is the first way in which we can know a unit vector. The second one is by using their components. For example, I have right here y and x, as we have right here. And I have right here a little vector that, for example, I'm going to call it, I don't know, t. That t is going to generate an angle between the x-axis and the vector, which I'm going to call, for example, alpha. The unit vector of t is going to be given by the cosine of that angle in the I direction, plus or less, that depends on the direction of the vector, as well as this part, as well as every part of the vector, every component, by the sine plus sine of the same vector in the j direction. Right? As you can see, this is playing with magnitudes and this is playing with angles. This is important for us to know for when we want to solve this exercise, this kind of exercises. So this is important for us to know, but in this exercise we're not going to use it. We're going to use this formula. So as you can see, the vector f is pointing towards this same vector, which I'm going to call it, for example, I don't know, vector L. So this is going to be my vector L, and this vector L is given by two different components, the 7 towards this direction and the 11 towards this direction. As you can see, the 11 is going to be negative because it is pointing contrary to the direction of the positive numbers for y, right? So the 11 is going to be negative. For when we want to know the components of the vector L, is going to be equal to 7 units positives along the I direction minus 11 units in the j direction. Now we're going to find the unit vector of L. The unit vector of L is going to be given by 7 divided by the square root of 7 squared plus minus 11 squared, the I direction, minus 11 divided by the same thing, 7 squared plus minus 11 squared along the j direction. Please remember this concept. Why is that? Because the unit vector L is going to be equal to the unit vector of f, right? Now we have found the unit vector of f. Please now remember this equation. Why is that? Because the unit vector of f is going to be given by the vector divided by its magnitude. So if I have the unit vector and the magnitude, I should be able to find the components of the vector. Why is that? Because the vector is going to be equal to the unit vector multiplied by the magnitude of the vector. That means that the vector f is going to be equal to 10, the magnitude, multiplied by the same thing. Copy, paste. All we have to do is to multiply this 10 by this part of the equation, and then this 10 by this part of the equation. So 10 multiplied by 7 divided by the square root of 7 squared plus minus 11 squared. I don't know if I've said this past, but I want to repeat it if I said it. For when you want to know the magnitude of a vector, all you have to do is to apply the Pythagoras theorem. Why is that? Because right here we have the component in the x direction, the component in the y direction. All you have to do is to evaluate the square root of every single one of the components to the second power. All right, add it, and you should be able to find this, which is the magnitude of the vector. That is the reason of this. So we can continue. The unit vector f, the vector f is given by 5.3687 the I direction minus, remember this minus, this 11, so 8.4366 along the j direction, and this is in pounds. Remember, if they gave you the units, you should place them in the final result. And this is, guys, how you can resolve, or you can solve this exercise.